Harkin and Henning.
Yay!
Tutorial on
Circuits.
Ooh. Electricity.
Yep.
Not quite as shocking.
No, not quite as shocking, or hopefully not shocking.
We're talking about electrons again.
Those electrons are just busy moving all the
They
time.
are moving.
Yes.
And when we can get them to move in a constant flow in a circle, which is why it's called a circuit. This science stuff.
It's pretty easy.
It's pretty easy. So we got electricity flowing in a circle, which we would call an electrical circuit. We're going to show you not how to build those circuits because you're going to figure that out.
You're going to do that.
You're going to figure that out. But we want to show you how to draw it just like electricians
Yes.
who really make a lot of money.
Yeah.
Like a lot of money.
Like a lot of money.
Like 3-digit kind of,
Yeah, a lot of money.
Yeah, a lot of money.
But you have to know how to draw it. So even if you know how to build a circuit, it's important that you know how to draw it the way we want you to draw it.
So we showed you a circuit that's completed, and now we want to show you how you would draw that circuit. Let's start with the easiest part, and that's the wires. What should I do with this information, Ms. Harkin?
I need to write this down.
I need to write it down, too.
So, lab notebook time.
We're going to title this Symbols for Drawing, whoops, that's a W, circuits. And we're going to put that in our notebook. So I'm going to list 8 different things.
8 things.
And I'll just go right down in order, and then we'll make the circuit themselves. Okay. So we're going to start with wires. That's a wire. It's a straight line. So that one's the easiest thing there is.
So like this.
Yes.
Wire.
Except when we draw it, it's just a straight line. Number 2, your batteries. Your batteries have a positive and a negative end, and we represent that with 2 parallel lines. One's longer than the other one is shorter. The longer one is going to be my negative, and my shorter is going to be my positive end, because the electrons need to move.
Yep, they gotta move.
So that's all you do. You do 2 parallel lines, and then you identify the longer line as negative and the shorter one as positive. Okay. Number 3, I'm going to put these 2 together.
Oh, because the wires have to hook to the battery.
Right. So here's a wire, and it's going to be hooked up to the negative side. Here's the positive side. I'm going to have a different wire. So this is wires and batteries together.
Just like that.
Oh, thank you.
Yep.
Okay. Then we're going to do switches. Switches are, yes, like light switches, except they look a little different in our circuits because they look like this.
We just have simple switches.
And they lift up to be opening them, and we close them down to close them.
Yes.
So open, close. That's a switch. Now your job is going to be to figure out when it's closed, is that good? Is that the electrons going through? Or is it when it's open? But you can figure that out.
You'll figure it out.
Okay, so switches are actually 2 dots. And then the switch itself, this part right here, is just a line in between. So when we have them connecting, that means
it's closed.
It's closed. And we got to figure out, does that mean the light's on or off?
I don't know.
To show that it's open, we would use those same 2 dots, but we would have the light line, or the switch line, actually up and not connected to the other side. So that would be open.
Just like that.
Just like that. And let's see, what is that?
Switches and wires.
Switches and wires. Oh man, we're getting combinations here. So now I'm going to have a wire, because that's a straight line, and a switch. Should we open it or close it?
Maybe close it.
Okay, close it. So then I'm going to just put another, remember, is my switch, not a wire in there. And then I add another wire to the other side. This is my switch and wires. Number 6. Woo, we're just booking.
Yeah.
Oh, let's do a light bulb.
Okay, light bulbs. Here, I got it.
So we're going to do a light bulb next, and a light bulb is simply a circle with a squiggly line in between it.
Easy.
That's a light bulb. Now, of course, number 7, we're going to hook up the light bulb with some wires. Here's the tricky part. I got to make sure that my light bulb squiggly is connected to my wires.
So you mean I wouldn't want to just draw random squiggles in my circle
Yeah.
just so I can get it done really fast like that?
Like that doesn't work.
No. So if I did that like on an assessment or something, that wouldn't be good?
No,
No.
that
Okay.
wouldn't be a right answer.
So I have to take my time.
Oh, yes.
Oh, yeah.
Because we're smart.
Time. Yeah, we're smart.
Sorry. And then the last one, because we have all kinds of other appliances that we can connect to our circuit, we call them resistors. So things like when we put in our toaster, or we put in a fan, or we put in a buzzer, all of those things, we don't want to be drawing them.
No.
So we use this symbol for resistors. And it's kind of a light bulb without the circle. So you simply squiggle line. That's a resistor.
You know what that looks like to me?
What?
That looks like kind of like a heartbeat,
Kind of does, doesn't it?
Yeah.
So this is really all kinds of appliances. That's it for right now.
All right.
Let's come back and we'll put all these together for our actual circuit drawing.